All right, area and area conversions. What is area? Area, in my mind, the way I think of it is like this. I think an area is a size of a surface. And it is a scalar quantity. It is not a vector. The direction, it has no direction. It's just a size or a magnitude. And how do we measure the size of a surface? Well, let's talk about a desk. Let me draw a kid's desk here. And this is going to be a horrendous drawing, but you should be used to my horrendous drawings by now. Okay, so here's a desk. It's got 4 legs on it. Yep, I told you it was going to be horrendous. All right, so the surface of this desk right here has an area. How can I figure that out? What is the area? Well, I need to know 2 things. Since it's a rectangle, this is pretty easy. I need to know this dimension. I'm going to call that width. And then the front to back, I'm going to call that length. To get the area, area is just length times width. And let me make up some numbers. I'm going to say that this desk is 40 centimeters wide, and from front to back, I'm going to say that it's 30 centimeters. So I'm just going to multiply those 2 together. I'm going to have 40 centimeters times 30 centimeters. 4 times 3 is 12. Stick on a couple of zeros. And my units, what are my units? I started off with centimeters, and when you multiply centimeters by centimeters, what you wind up with is square centimeters, or you could say centimeters squared. I don't care really how you say it, but so that's our answer. That is the area. Our area is 1,200 square centimeters for the surface of this desk. Okay? So that problem was really easy because we were just talking about a rectangularly shaped object, you know, just length times width. Boom, you can get your area and you're done. Can you find areas of other surfaces? Like can you find the area of a sphere? Think about this. Think about a globe. If you were going to take a globe, and let me try and draw one here. I've got an image I'm going to share, but let me see how I can do first. So here we've got like a 3D circle. That's supposed to be a shadow. Isn't that nice 3D drawing? Okay, yeah, my drawing sucks. So anyway, imagine that you've got a globe and you try to slice it up into pieces so you can spread it out flat on a desk. Okay, I'm giving up with my drawing. Check this out. So this is what a globe looks like, the Earth looks like if you could take its surface and spread it out flat. And so then what you could do then is now you could go through and you could figure out the area of all these things. And you could find the area of the surface of the Earth. And just for the heck of it, I did Google this, and what is the surface area of the Earth? Oops, I clicked Google by mistake. Okay, here we go. The surface area of the Earth is 196.9 million square miles, or you could say miles squared. Or metrically, the surface area of the Earth is 510.1 million kilometers squared. So yeah, it's a pretty big object. So that's, you know, you can find areas of weird shaped objects too. Okay, next. I want to be able to convert areas from one area to another. So I'm going to go to Google really quickly here, and I had typed in surface area of the Earth. I'm going to type in, how about this? I'm going to type in square inches to, how about that? How about square inches to square feet? So let's see here. 1 square inch is that many square feet. I think I'd rather have the 1 over here. So okay, so 1 square foot is 144 square inches. Let's talk about that for just a moment. So what do we have here? We have 1 square foot, kind of like the tiles in my classroom. They are 12 inches on each side. So if each one of these dimensions is, you know, 12 inches, and one of these we call the length, the other one we call the width, 12 times 12 is 144 square inches. So that means that 144 square inches equals 1 square foot. So if you choose to use 12 for this, you get 12 times 12, you get 144. Or if you want to, you could use, instead of 12 inches, you say 1 foot. And 1 foot times 1 foot is 1 square foot. So those things equal each other. So this is a conversion problem, or a conversion factor, and this is the same sort of stuff we messed with a lot in the first semester, so I think these problems are going to be really easy. So let's say that you're in a room, and the room has an area of, I don't know, 200 feet squared, and I'm asking you to convert and find out how many square inches that is. It's going to be a pretty big number because we're going from feet squared to inches squared, so we're expecting a large number. And so this is something you've seen before. You write down what you were given, 200 feet squared. You can write it over 1 if you want to. I normally skip that, but you can. Oops, not equals. I want to go times. I'm going to multiply by a fraction. I want to get rid of square feet, and I want to go to square inches. 1 square foot is 144 square inches. And so why did I do this? I did this so I could cancel out feet squared, and then I could wind up with my answer, inches squared, and that's what I wanted. So all I've got to do then is go 200 times 144. Should I be able to do that in my head? Let's see. Double all those. So 2, 8, 8, and keep my zeros. So there you go. If you have a room that has an area of 200 square feet, that is 28,800 square inches. So conversion problems like this should be a breeze for you.